Amanda conducted a survey of teen gaming preferences. Here are results. 20 teens play online gaming. There's online. 20 play a game on a game console, like Xbox or Wii or whatever. And 20 play on their cell phone, like Angry Birds or something. I don't know. What's the new Angry Birds? Is there a new, like, fad out there? Yeah. There's, like, I don't know. Bejeweled? I don't know. Okay. Is that what it's called? Is that what it's called? Tetris? Okay. She surveyed only 31 teens. How is this possible? How is this possible? Okay. Some teens play what? Some play more than one. They can play. There's probably some that play two. And there might even be some that play all three. Right. So, ooh, 3 Venn diagrams. Ooh, okay. Okay. So, we have a whole different situation we're dealing with here, because now we have parts that are A only, okay, B only, C only. We have A and B, we have A and C, and we have A, B and C, and then we have A and B and C. What? Yep. A and B and C. So key ideas here. Set theory is useful for solving many types of problems, including internet searches, database queries, data analysis, games, and puzzles. So to represent 3 intersecting sets with a Venn diagram, use 3 intersecting circles. When we're solving a Venn diagram like this, my tip for you is always work from the inside out. What part would be the inside? H, yeah. Figure out H, then figure out your next overlaps. So that would be E, G, I. And last, get D, F, J, unless they're already given to you, okay? So the most complex situation we're going to actually look at today is, what if we actually, the middle is the unknown, and we have to use a variable of x, and then solving for that variable, for what the overlap would be. So the notation, A and, remember this is and, intersection, B and C would be the H region, H and B, A and B, sorry, A and B would be E and H, together, added together. A and C, okay, is represented by the union of G and H, and then so forth. So we have this crazy formula here, that the union, let's talk about this. So this is the union of A, B, and C. A, B, or C, I guess. A, B, or C. So the area of A, B, or C, the union of them, is equal to the number in A. So that would be this whole region here, plus B. Now, I just added B. What did we actually do when we added the whole part of B? So I've already added A, and now I've added B. What just happened? Did I add anything twice? Yeah, which part did I add twice? Is it represented there twice? E and H, okay? And then if I add C on top there, I've also now added G and H an extra time, and H and I an extra time. So we have to subtract off those intersections, because we've already added them on another time. If we subtract this off 3 times, though, we have to add back the intersection, because we subtracted it 1 too many times. So we have to add back H. So this giant formula here is what we're going to be working with today. Woo, that's a nice one. Will that be on a formula sheet? No. No, it's not on your formula sheet, but we'll practice using it, but we can also use logical reasoning to work our way through the problems without the formula. Okay, so turn the page. Okay, let's skip this part and go down to the example. Use the following clues to answer the questions below. 20 children have a dog, a cat, or a bird. So let's draw our big set down below. So our three situations. Our dog. Try and make, one thing when you're drawing these, try to over-exaggerate that overlap because it'll give you more room. Oh, that's ugly. Wait a second. Haha. Uh-oh. It's not what I wanted to move. There you go. Okay, like that, and one more. Oh. You want to have room for your intersections because numbers are going to go in all different areas in there. So we have cat, dog, bird, C, D, B. Should we go alphabetically? Sure. B, C, D. Nope, doesn't matter. They'll work the same. Just label them so you know which one we're filling in. Okay, let's go back to our information. So it says 28 have a dog, a cat, or a bird. So that's the union of all three. Okay? The union of all three. Can I put that in anywhere right now? No. Remember, you want to try and work from the inside out. So if we want to find who has a bird, cat, and dog. So going on, 13 children have a dog. Okay? And so I find it helpful kind of put this. We know the total of, where's dog? Down here. 13 have a dog. Total. 13 have a cat. And 13 have a bird. Now right away I know there's going to be overlap because 13 plus 13 plus 13 is more than 28, the union of all three. So there had to have been an overlap. 4 children have only a dog and a cat. 3 children have, so that's going to be, again, this harsh only dog and cat. Ooh, we can fill that in. Where's only dog and cat? Does anyone know where that is? Bottom right. So only D and C is down here, and this would be only dog and cat. See this portion here, right there, represents dog and cat, but only dog and cat, that means not all three, there's no bird, would be just this portion right there, only dog and cat. 3 have only a dog and bird, so D and B, that would go right here, 3. And 2 children have only a cat and bird, 2. No child has 2 of each type of pet. What? Oh, nobody has 2 dogs or 2 cats. Right, thank you. I'm glad you could interpret that. Okay, and we're also assuming one more thing. We're assuming that there's also nobody who has no pets. So everybody has a pet. Is that set up anywhere? It says 28 children have a dog, a cat, or a bird. So this is the union of all three. So it doesn't matter. Okay? So the union of all three is 28. Now, could we figure out this portion right now? Is that possible? No, it's not possible. Okay? So why not? What do you always have to have no first? In order to figure out this, what would I need? The very middle. So in these, you always want to work from the inside out. So the number who have, I'm going to write this on the side, a bird and dog and cat, we don't know. So we're going to call that something because we have to work from the inside out. So what do you want to call that? Pick a variable. X, sure. We have to call that X because we have to work from the inside out. Okay? We have to work from the inside out. Now we know, okay, I know those who have a bird and a cat would be X plus 2. Those who have a bird and a dog is X plus 3. And those who have a dog and cat is X plus 4. Could I figure out how much goes in here now? So how many would be a bird only? And you can write that two ways, just B only, or you can write it as B excluding the dog, excluding the cat. Two ways to write that, okay? We know that these four portions add to what? 13. 13. And so this only bird is going to be the total minus these guys. Would you agree with that? Because all four of them is add to 13. So 13 minus the sum of these guys would give you your fourth portion, because the sum is a total of 13. So 2 plus x plus 3, we can write as x plus 5. I'll do it in a couple steps. Or, simplifying this, 7 plus x. I can show you with the formula on the front page after, but for now I just want to reason through it with you. 3, I don't know. There you go. 5 plus x, okay? Now be very careful with subtraction. If we're subtracting this, we had to have brackets, but we distribute the negative to each one. So it becomes 13 minus 5 minus x, if we bring in the negative to each one of them, distributive law. Or what's 13 minus 5? 8 minus x. We have to distribute in the negative. So if we think of it this way, 3 plus 2 is 5, right? So out of 13, we've already taken 5 away. So this is going to be 8 minus this x. So if we add these all together, this should be equal to 13. Okay, so that's that portion. Okay, now let's do here, this portion. So this of C only. Another way we could write C only is the set of C excluding birds and dogs. Okay, so the total we said was 13. They already have how many added together? 4 and 2 is 6. So it would be 13 minus the 6 and minus x. That's another way we can actually work it out. So our total number is 13. Take away 6 and take away x would give me what's left over, which gives you what? 13 minus 6? 7? Yep. 7 minus x. Okay, and the last part, D only. Or we could write that also as D excluding birds, excluding cats. So again, all of these four numbers, 1, 2, 3, 4, will add to what? How many total dogs? So we'll have dogs. 13 minus these, let's take these away. So 3 and 4 is giving me 7. So take away the 7 and take away the x. And we'll be left with this portion here. 13 minus 7, 6 minus x. Okay, so now that we have that, we can actually figure out what x equals. How can I figure out what x equals? What else do I know about all of this? There's something else they told us in the very beginning. Equals 28. The union, all of these added together, the union equals 28. So can I make a system of equations here? Yes. So we know the union equals 28. So the number of dogs or birds or cats equals 28. The union of all those together. So if we add these all together, this should equal 28. So 28 is equal to, so let's add them all together. we have 6 plus x. Oh, no, not plus. 6 minus x plus 3 plus 4 plus x plus 2 plus 7 minus x and 8 minus x. So we're adding all of those together. So we had you could put these in brackets if you like. They don't need brackets. So there was 6 minus x, there was a 3, a 4, the x in the middle, 2 for the dogs and cats only, 7 minus x, and 8 minus x. All of those together adds to 28. Is everyone following right now? Yes? Okay, good. Okay, so we can collect some like terms here. With addition, we actually don't really need brackets. So let's add the numbers together first. 6 plus 3. Use our head. 9 plus 4. 13 plus 2. 15 plus 7. Where were we? 22? 22 plus 8. 30. Oops. 30. Okay. So if I have a negative x and a positive x, what happens with that? Negative 1 plus 1. They cancel out. And then we're left with minus x minus x. So we're going to have how many minus x's? 2 of them. So now we have this equation to solve. We're almost done. We can figure out what x is. So 28 equals 30 minus x. 30 minus 2x. What's the next step? No, it's a binomial. We're going to add or subtract. So this is a positive 30. Which gives you negative 2 equals negative 2x. Now that it's a monomial, divide both sides by negative 2. And what does that give you? 1. Okay, so how many had all 3? How many children have a cat, a dog, and a bird? So 1, have all 3. And then they're asking, how many children have only one pet? So if x is 1, who are the ones that are only one pet? Which part of the circle? The outside portions, right? The B only, C only, D only. That would be one pet. So, just going down to the bottom here. So how many had all 3? 1 student. That was the first question. The second question was how many had only one pet? Okay, so how many had only a dog? If x equals 1. 5, because it was 6 minus x. Okay, how many had only a cat? 6. How many had only a bird? Bird was 5. Was it 5? Where are we? Bird, 8 minus 1 is 7. Okay, so the sum of that is 7 plus 6 plus 5, or 11 plus 7 is 18, had only one pet. That's the toughest, the toughest that you'll see in a situation like that, where you don't know your inside, because you always need to know the very inside and work out whenever we have these problems. Same with a two-part Venn diagram, right? We were always looking for that intersection first, and then we work out. So if it's not given, then we have to use variables. Now, we could use the formula as well to figure out, remember this formula here? We could use this to figure that problem out as well. Okay? You still would have had to put in variables, but it might, if you know this formula, it can make it a lot easier. It's up to you to decide that if it does. So really quickly, if I can copy and paste this, let's do that. I just want to show you with the formula. And where'd it go? here. Cut and paste. So this problem here, I don't know if you have room. Do you have room on your page? No? Okay, it's up to you if you write this down. I'm just going to show you really quickly. So the union of A, B, and C. So in this case, the union of the bird, cat, and dog was 28. Equals. How many total people had, so we'll use A as, I'll rewrite the formula. So the number of birds or cats or dogs equals the number of people who have a bird plus the number of people who have a cat, so the number of people who have a dog, minus, because we've added the extra intersections, the number who have a bird and cat, take away the number of a bird and dog, and take away the number of a cat and dog. Because we've subtracted off the middle one too many times, we have to add the intersection of bird and cat and dog. Okay, so using our chart up above, the number of total people who had a bird was how many? How many people had a bird? 13. Plus, how many people had a cat? 13. How many people had a dog? 13. Minus, how many had a bird and a cat? What would this represent? Bird and a cat. How would you represent that? X plus 2. Okay, so those who had a bird and a cat would be x plus 2. We add those together always. So x plus 2 minus those who had a bird and a dog would be what? Bird and dog, x plus bird and dog. Bird and dog, x plus 3 minus cat and dog. So cat and dog would be x plus 4. And then subtract, or so add back on the intersection of all three, which we called x. Okay, so this formula could also work to solve it as well. 28 equals, this would be 39. When you have a negative in front of the brackets, what do you have to do? Distribute. So it becomes minus x minus 2. Take away x minus 3. Distribute that negative and distribute this negative. Negative x minus 4 plus x. One of the x's cancel out. I'm just going through this quickly. It's algebra at this point. We're left with 28 equals 39 minus 2 is 37. Take away 3 is 34. Take away 4 is 30. Do you recognize this? And then we have negative x minus negative x. We're left with the same expression we had before. Take away the 30, we get negative 2 equals negative 2x. Divide by negative 2, x is 1. Okay, so another way to do this is with that formula. So one is using the formula, knowing the formula, and working with it. And you can really understand the formula if I have b plus c plus d, you have to subtract these overlaps and add back on one center. Okay, and if you do that, you can use the formula. Or you can logically reason through it like we just did. Both would work. Okay, turn the page. We're not doing number 2. Oh, no? Oh, it just says number 3? I forgot to change it to a 2? Okay, good. A total number of 58 teens attend a sport camp to train in at least one of 3 sports. Swimming, cycling, and running. So let's draw that out. Yeah, sure. So swimming, cycling, and running. Infinite. And here. Okay, so we have swimming, cycling, and running. And a total of 58 attend. So that's our universal. There's a fifth number in the universal set. And they all train in at least one of 3 sports. Okay, so will there be anybody on the outside? No. 35 train in swimming, 32 train in cycling, and 38 trained in running. Okay, so we know 35 in swimming, the total in swimming is 35. We know the total in cycling was 32, and the total in running was 38. So we know, for example, all 4 of these for swimming would add to 35. 9 trained in swimming and cycling but not running. So where would that go? Yeah, the top intersection is swimming and cycling but not running. So that would be swimming and cycling only. 11 trained in cycling and running but not swimming. So that would be cycling and running only. And 13 in swimming and running but not cycling. So swimming and running only, 13. Okay, so again, this is very similar to the last problem. Did you want to try this one on your own? Yeah? Try this one on your own, okay? So they don't give you the inside. What are you going to call that? Okay? What are you going to call this? X. Now, I'm going to pause the video here. I want you to try it. You could either use the formula. Okay, if we made the formula, the number in the union of all 3, so swimming or cycling or running, would equal the number in swimming plus the number in cycling plus the number in running. Because we added those, we have to subtract the 3 intersections. So minus the number in swimming and cycling, minus swimming and running, and then take away cycling and running. Because we took away the 3 intersections, we have to add back on the center. So plus the number in swimming and cycling and running. Okay, so you can use the formula if you like, or you can reason through it like we did first. Okay? So first without the formula, and then after with the formula. Okay? So without the formula, I know this full circle of swimming, it totals 35. So then 35 minus these 3 would give me what goes in the circle. Well, 13 plus 9 is 22. 35 minus 22 is 13. And so the 13 minus x should go in that circle there. So how did I get that? Again, it's 35 minus the sum of the 3 of those. 9 plus 13 plus x. Don't forget to distribute. So this is s only. So if you distribute the negative, you get 35 minus 22 plus x, or 13 minus x. Okay? If I want r only, running only, okay, it's a total of 38. So 38 minus those 3, 38 minus 13, minus 11, well, this is 24. 38 minus 24 is 14 minus x. Okay? Did you get the same thing if you did it this way? Yes? And then if we want cycling only, the number of cycling only, the total is 32. So 32 minus 11 minus 9 and minus the x, because we want to subtract these off to get what's left over. Well, that would be 12 minus x. Okay? And so now that I know all my circles, what should all of these add to? All of these together add to? How many total people were in this event of any one of these? Of cycling or running or what else is there? Swimming. Total of 58. Okay? So then 58 equals, I'll do it down here. So our total of the union is 58 will equal the sum of all of these. So 13 minus x plus the 9 plus x plus 13. You just have to be careful that you don't forget one of the circles or one of the portions of the circles. Okay, so adding this all together, I get 58 equals 2 of the x's. We have a negative x and a positive x. That cancels out. Adding all those numbers, you get 72, and then minus 2x. Subtract the 72. I get negative 14 equals negative 2x. Divide by negative 2, and you should get 7 is all 3. Okay, so before I answer the final question, guys, just really quickly, if you use the formula here, so the union is 58 equals the number in swimming was 35 plus all of the cycling equals 32 plus all of the running is 38. Subtract the overlaps, x plus 9. My next overlap I'm going to take away was x plus 11. And subtract x plus, I'm missing one, 13. As I've subtracted off those overlaps, I've taken away the center, so I need to add back x. So when you do that, you have to distribute the negatives in. So it becomes negative x minus 9, negative x minus 11, negative x minus 13 plus x. 2 of the x's cancel again. And we're still left with 58 equals 72 minus 2x. And we solve again just like we did, and x equals 7. So what's a triathlon? When you do what? All 3. So who's involved in it? How many people are in the triathlon? The answer is 7. Okay. Now, if you wanted to fill in the rest of them, how many teams might be training for the triathlon? It would be 7. So once you know this, you can go back to answer other questions. This was 7. Right? This became 7. So 11 minus or 14 minus 7. This area is 7 as well. 12 minus 7 is 5. 13 minus 7 is 6. So you know the rest now, and you could double check your answer. Do all of these add to 58? Yes, they do. Okay? This is as tough as it gets. All right? Tough as it gets. There's a situation like this. Not till after spring break. Okay?